Hello, good evening, girls. How are you, people? I hope everyone is in their good health, including their family members. Okay, so let us start with today's topic. Actually, the topic is the storage strategies. I couldn't mention it on the top, but the topic is of storage strategies. Over here, I'll be showing you what are the four different storage strategies that are available. So, starting with obviously storage strategies, this is no different from the memory which I was talking about in my last three videos. It is the computer memory or the storage strategies are one and the same. We have altogether four strategies, as we have four different segments for the memory. In the same way, there are four different strategies, four storage strategies available in this subject of compiler design. So as you can see, the first strategy, the first storage is the code, then is your static and global segment, then is stack, and then is heap. You all are aware of this thing? Okay, so now you all, I hope everyone is very much clear with this one now, that what is meant by code segment. See girls, when we type a program and compile it, then what happens? It gets converted into the machine code. Now this machine code gets loaded in the code segment of the main memory. The entire code gets loaded in the code segment. Now you observe over here that in the program which I have written over here, I have three variables declared. Now all these variables belong to the function main, so they are local variables. So now let me say they are local variables. Okay, now coming to the second segment of our computer memory or the storage strategy, it is static or global. What you mean by static and global? See girls, whichever uh, variable is declared global. Global means the variables which are declared beyond the functions. It is not declared inside any function, it is declared beyond the functions. It is known as global. Or a variable whose lifetime is throughout the program, sorry, variable, or the variable who is declared as static, i.e. its value doesn't change anywhere in the program. Such variables are placed in this section of the memory. I repeat, the static variables whose value doesn't change throughout the program, or the global variables who are declared beyond the functions, is stored in this memory, in the second segment of the main memory, or in the second storage strategy. Okay, now the next thing, what is the next segment of the computer memory? The next segment of the computer memory, which you are very much aware of it, is stack. Now in this stack, all the local variables are stored. What are the local variables in our program? The local variables are int a, b, and c. All these variables are stored inside the stack. See what is the, like, integer take two memory spaces, hence a stored as 1000, b stored at 1002, and c stored at 1004, like taking 2 bytes each. Okay, now the actual thing which I want you to also understand through this video is the difference between stack and heap. So if the question comes to write about storage strategies, you can elaborate the code and the static global segment and write down the things in this same answer. Or you can simply, if the question comes as to explain the difference between heap and stack, then this original answer is enough for you. Fine, I hope you're clear with this. If the storage strategies come, then you need to include code as well as static and global section, which I have given you points on, and if they simply ask you about heap and stack, then go for this 3 pages answer. Okay, now girls, coming back to stack. In stack, I said you it is a storage, it is the storage segment for all the local variables. Now girls, what happens is the code which is running in this segment uses the variables present in the stack. See, code is in its segment, variables in it is in the stack segment. As per the use comes, as per the use arrives, the code what it do, it calls the variables from the stack. It uses the variables from the stack directly through their addresses. Okay, it goes and uses the variables directly. Now this is the major point which you need to note down when using stack. What's the point? The point is the code segment directly use the variables present in the stack segment. Now the second important point which you all need to note down is, see girls, the stack memory is static, means whatever space is allocated for the stack during the runtime is already fixed. You cannot change the size of the stack. So when does this size is decided? It is decided during the compile time. See, when we compile the program, at the same time it is decided, the variables are checked and the stack is allocated with the respective memory space. You're getting me? As per the availability of the variables, the stack is allocated its space. So during the runtime, the size of the stack is finalized. You cannot change the size of the stack during the runtime. Hence, we can say that the size of the stack is static. So, what are the two things related to stack? One is the code applies the stack or use the stack directly, and the second thing is the size of the stack is static. These are the two very important points to remember. Now, coming to the next thing. The next thing is about heap. Now, girls, what you mean by heap over here? See, firstly, let me say you why heap is different from the stack. As the first point, in the first point I said you that the code can directly access the stack, but that's not the case with heap. Like, code cannot access heap directly. This thing I have already said in the previous video also of heap management, but this particular video is for you to explain about the storage strategies. Okay, so over here code cannot access the now girls, the first thing over here to understand is, firstly, why is it necessary to have this heap? Can't we manage simply by you having stack in the memory? We can manage with it. Then why we need the heap? See, for that, see this particular example. Over here in this program, I have like 5 variables, and see, if I am in a regular business where I'm a programmer and my program is like getting developed on a day-to-day basis, then what happens? I need to introduce new variables as per the usage. Like, whatever is the usage of my program, my variables will be introduced in the program. So what happens at that time? See, now the major thing occurs. What happens? Stack size is already fixed. So when this particular program has been on the compilation, it has assigned this 5 variables for the stack. Now, if I am improvising this program by introducing more variables, I cannot do it because my stack is already fixed, right? So now for this purpose, I need to have an additional storage space where I can have more number of variables introduced, right? So for that thing, heap comes into play. Now what does this heap do is, it will, as I said, it will provide an additional space. But to use this heap, the programmer needs to keep this in mind. What's the thing? It needs to have the program written. The programmer needs to write the program in such a way that it is introducing, that it is having this that it is introducing, or sorry, declaring a pointer variable in the program. See, programmer already knows, like programmer, if the programmer is knowing that this program is not the final version, I can have many more changes for this program, I can have new introductions for this program. If such a thing is there, then the programmer, what he or she does is, he a pointer variable is declared inside the program. Now what happens, the variables as well as this pointer variable is allocated in the stack memory. Fine. Now when I want to have additional spaces for my program, additional variable spaces for my program, I simply use malloc function. See girls, about this heap management, I have already said you in the previous video what are the things needed to use the heap. One is the pointer and the other thing is the malloc, cloc functions, the dynamic allocation function. So over here in this program I have used malloc function. So by using the malloc function, I have assigned 10 spaces to the pointer variable p. So what happens, in the heap section 10 places are assigned, and the starting address, it is over here. If you see, I'm sorry, it is not clear I guess, but you can see that the starting address is 5000. That address is assigned to the pointer variable p. Now inside this pointer variable p, I have the starting address p. Now if I want additional spaces to be introduced, additional variables to be introduced, what I simply do is, I can use a space in heap. And one more thing, the heap space, like I have allotted 10 spaces, it is not necessary that I can only use 10. The space of heap can shrink or grow, so I can use more number of spaces also over here by having more malloc functions, or I can shrink the size as well. So now you can see over here through the diagram, code is not accessing heap directly. What it is doing, it is firstly going for stack. Inside stack it is accessing pointer variable p, and from there it is accessing heap. So such is the scenario where anyone can access the heap through the code only through the pointer. So at the end I can see that these are the differences in stack and heap. First one is code access the stack directly, whereas code access heap indirectly. The size of the stack is static, the size of the heap is dynamic. Yes, it can grow and shrink. Stack is only for the local variables, whereas the heap is used through malloc and through pointers. Fine girls, I hope I am clear. If you people have any doubt, then let me know through the comment section. I am regularly checking up the comment section. I want your feedback over the videos. I want you people to come up with doubts, and more 2 videos are coming up, so stay tuned. Okay, like in this like till tomorrow, two more videos will be coming in. Please girls, spend at least half an hour of your 24 hours on compiler design. This is a very 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 important subject, not to be taken on a lighter note. Thank you. Bye.